Flex Power modules are exhibiting at the OCP Global Summit in San Jose from the 9th to the 10th of November 2021, and here's a sneak preview of what we're presenting there. Artificial intelligence applications are a major driver behind some of our most advanced solutions, and the first to bring to your attention is the BMR 510 series. The BMR 510 is a two-phase voltage regulator module, or VRM. The mechanical design, which uses an LGA footprint with optional solder bumps, has been specifically designed to minimize board area requirements in datacom applications that demand high power density and small size. Delivering up to 80 amps of continuous current across two phases in a package taking just 10 mm by 9 mm of board area, the BMR 510 also delivers a peak current capability of up to 140 amps for less than 1 second. The input voltage range is 4.5 to 16 volts, making it ideally suited to complement upstream high-efficiency unregulated 4:1 conversion ratio intermediate bus converters, which typically operate from a 40 to 60 volt supply voltage. The BMR 510 has been specifically designed for topside cooling, and the low profile of just 7.6 mm means it can be located underneath heat sinks where necessary. It includes a full suite of protection features, including over temperature and over current protection, and the design is one of the first from us to be classed as halogen-free to meet the growing demand for this emerging environmental requirement. The device is capable of accepting tri-state PWM signals from an external controller, and full thermal models are available to aid our customers' thermal simulations. Here you can see a recap of the key parameters of note for the BMR 510. When supplying a core voltage of 0.8 volt to an FPGA, ASIC, CPU or GPU for example, the efficiency levels are up to 88.5% when supplied with a 13.5 volt input and 89.4% at 10.4 volt input. The switching frequency of the device is set by the external controller and can be in a range from 650 kHz to 1 MHz, but is optimized at 750 kHz. On the right hand side here, you can see a representative size comparison of the BMR 510 versus a dime. Next up is the first of two complementary intermediate bus converters, in this case the BMR 350. The BMR 350 is a non-isolated digital quarter brick DC-DC converter that provides a well-regulated 12 volt output at up to 860 watts of continuous power and 1200 watts of peak power for less than 1 second. Operating over the 40 to 60 volt input voltage commonly found in datacom environments, the quarter brick package device has a maximum height profile of just 12 mm, thanks in part to the novel baseplate design, and delivers a regulated 12 volt output at efficiency levels of up to 97.9%. Once again, this is a halogen-free design, can be paralleled for higher powered applications, offers exceptional thermal and price performance ratios, and is fully compatible with our Flex Power Designer design tool. An important feature of note for the device is the inbuilt event data recorder, commonly known as a black box, which records events leading up to and just after a failure, which really helps in terms of system failure analysis. Here you see once again a summary of the key parameters of the BMR 350, showing the max current levels of 72 amps continuous and 100 amps peak. Note also the switching frequency of 150 kHz and the low ripple and noise characteristics of the device. Finally, in this video overview, we come to the BMR 310 series. The BMR 310 is built on the proprietary zero voltage switching switched capacitor converter technology of Infineon Technologies and achieves efficiency levels of over 98% at half load and can deliver power levels of up to 860 watts continuously and 1060 watts peak in a compact, fully SMT compatible package measuring just 57.9 mm by 25 mm. It operates over an input voltage range of 40 volts to 60 volts and delivers an unregulated, non-isolated output voltage of between 10 volts and 15 volts using a 4:1 conversion ratio. One key benefit of the switched capacitor design is to lower the overall height of the device, and the first variant, which includes a base plate for easy cooling, is just 9.9 mm high. This already makes it possible to locate underneath generic heatsinks, but future open frame designs promise even lower profiles, down to 6.5 mm. Once again, the BMR 310 can be paralleled for higher power applications and is fully compatible with Flex Power Designer. A summary of the key parameters of the BMR 310 can be seen here. It's important to highlight that in many data center applications, since isolation is often provided by the front-end AC to DC converter, there is no need for further isolation at the DC-DC converter level, and this enables us to bring new topologies, higher power densities and higher efficiencies to these challenging environments. With that, all that remains for me to say is that we look forward to seeing you all in person at the OCP Global Summit in San Jose.